Would omega be greater than 0? A damped sinusoid x of t equals a e to the... This feels like a differential equation. The answer to a differential equation. How are the successive zeros of x of t always the same distance? That doesn't seem possible. Oh wait, I guess it would be. I need to see what this looks like. Oh wait, so I guess it's like a normal cosine graph. It's just the amplitude that's going up or down. When t is very large, let me just graph this because it'll be easier to look at than to say. I don't want 3D Desmos. Just give me regular Desmos. Leave graphing calculator. Y equals e to the minus t cosine t. Okay. Well, that's not as helpful as I hoped to be, but it just blows up quick, but do we have like really tiny? Yeah, we have really tiny fluctuations over here and then really big fluctuations in the amplitude gets bigger or smaller is the theme of what I'm trying to say. So let's go back to their question. Now, the space between successive maxima. Well, I wonder what the definition of spacing is. Because the actual distance should be different. But if I just mean the horizontal distance, I imagine that would be the same. Or maybe not. Taking the derivative is probably a good step, though. X prime equals minus a e to the minus at cosine omega t minus a omega why is there another minus? I think that's a typo. I have a hard time knowing for sure. They combine the cosine. Okay, the cosine and the sine is just one single cosine with a phase shift and a constant. I bet you that's valid. I don't know offhand what that formula is. Shouldn't... Why is that a there, though? There's no a over here. This is the solution. You cancel the capital A constant. I think their derivative is slightly wrong. I kind of want to work this out on the board though. Let me bring this up in the browser. Okay. Keep the cat there. The cat's the most important thing on this board. Let's do black. Okay, so we have x of t equals a e to the minus alpha. It was alpha, right? I can't tell when it's that small. No, it's not alpha, it's just small a. Was it cosine omega t? Okay. So they use dots for their derivative, so I'll do a dot as well. It is a product rule. Doing the e first, minus a e to the minus a t, cosine omega t. Now we derive the cosine. Cosine derives the minus sign. And we set equal to 0. So the a's can cancel out, the negatives can cancel out. E to the minus at is never 0. So it must be that a cosine omega t plus omega sine omega t is equal to 0. Subtract over the sine, subtract over the cosine, just to make it match what the solution is going to say. Minus a cosine omega t, divide each side by cosine, divide each side by omega. Sine over cosine is tangent. Minus a over omega is where the maxima occur. I don't know exactly how you interpret that in terms of the actual question, but now that we've, I think that we agree with the answer key for what the derivative is and where it equals to 0. So I say it doesn't depend on t or x. So I guess they're saying that it's always the same. I feel like I don't understand the actual context, but I think I understand the math that's happening. So I feel comfortable enough writing an answer here. Should be x prime t equals, what did I say? Minus a e to the minus at cosine. Oh, you know, I never started up the music, did I? Doesn't really matter that much. Let me just find some kind of lo-fi playlist. Considering that bro card angle, probably your brain is still pretty fried. Well, yeah, that's why I moved on from that one. Oh, so, oh man, so Omega in tech just slash Omega, is it that easy? Let me bring up my cheat sheet. If I can find it. Here it is. Slash Omega. Okay, yeah, it is. You were sick for 5 to 6 days last week? Oh no. Today's first day back at work to show you also. Oh god, yeah, don't do math. A slash Omega e to the minus at sine at. Don't do math. Don does math 2024. Since your kid's birthday, you'll like to take everyone out for dinner. They're organizing the when, where, how. Oh my god, Jed. That's. I'm sorry that you have to do everything when you're still sick. I guess so, Jed. I don't mean to, but it's like I don't know. I feel bad everything is like falling on you, and it's a little funny. Does my misfortune cause you mirth and glee? Apparently it does. You know, do you take pleasure in the torment of others? You know, I think you have your answer to that question. No, I hope things don't suffer. Don't do math, suffer. I hope you feel better and hope that you get a break. You know, sometimes like, you know, when things are bad and there's no solution, all you can do is laugh sometimes. So I laugh at my own misfortune too. How about that? Oh god, see? Okay, now you get to laugh at my misfortune. 78 times 46, that's like 80 times 46. 80 times 8 times 46. 8, carry the 4. Hey Jeff, happy New Year's to you too. 8, carry the 4. 368. Add a 0, 3680. 3680 minus 2 times 46. 3680 minus 92. 3680 minus 92. 3680 is 35. $88. 3588. Is that right? I got it right? No way. I actually did one right for once. I need to see it to believe it. $35.88. Hell yeah. I'm taking those points and running. It's the dawn of a new year. It most certainly is. You have a question. You know Lagrange converts convolutions into multiplication. A plus? Oh. Oh, for a second I thought I I didn't see that Zach is the one who said the plus. I thought you were correcting yourself, Jeff. Um, yes, it's been so long since I've done a convolution. Integral, I do remember the plus transforms being involved though. I'm very rusty on this though. How do you do not equal to? Is it NEQ? Yeah, NEQ. Along with negative A. To get A cosine slash omega t plus slash omega sine AT equals 0. It's a symbol operator that converts functional composition into something else, not multiplication, because composition isn't commutative. Maybe. Let me finish typing this out. I don't know one off the top of my head. Okay, hopefully this tech actually works out. No! Well, actually, let's... Oh, the slash... It didn't like the slash omega. Do I need a space, maybe? Does that fix it for those? Okay, yes. I need the spaces after the slash omega. I thought you didn't want the space. Ah. No. Omega. Did I get them all? Let's find out. Okay, it compiled. Wait, that should be sine of AT. Why am I writing sine of AT? It should be sine omega t. Oops. Omega. Okay. Taking the message some of the streaming her. Oh, good. Actually, who am I kidding? I'm probably not going to come up with, with another idea for you though, Jeff. So even obvious that functional square root of x squared plus 1 is even analytic. Oh, is that what's called a functional square root? It's kind of interesting. Yeah, this question's definitely weird. Like, when you make the t distribution, I think you throw out the 43 for now. Doing this, yes, squared link from the math Discord, but it's dead. Task and answer programming questions. Ooh. I don't know one offhand. I only know a tiny bit of programming, so I don't feel like confident in helping. I know that Zach has done some programming questions. I don't know the extent of his knowledge, though. I'm trying to think. For official or at least busy discords. Some random C++ server feels ding. Yeah, I'm not sure. Like, if you're working on like a specific project or using a specific library, there might be a Discord dedicated to that like type of thing, but I'm not sure. Like, if you're doing like the GIS stuff that you're asking about, there's probably a server related to like libraries for that that could help. That's my only other like thought though, because I haven't looked for servers like that or for computer science servers myself, so. They have like 10 people each. Oh, okay. T equals 22.2. What is our n? N equals 8. You seek the grail of programming servers. Oh, I don't know about that. Oh shoot, how do you interpret the top rows? This is like one-tailed and two-tailed. And the initial question was, you measure such a high wind speed. There's a real math Discord you joined. Yeah, that's true. Yeah, I mean, I know referring to the one that was like in this list. I'm kind of curious. I know they have like a bunch. Yeah, the computer science. Wow, I mean, it's a bunch of. I guess this one's like 200,000 though. They got a lot of like yeah. So I don't know one offhand, but join the ones you wanted. Yeah, I was just like curious to see for myself what was in there. So I want to just quickly look up a T table, just to, because theirs is in probably Dutch or something like that. And I just want to like remember the context for what a T table actually means, because this is important to the question. Place for questions, really? It's really weird to me. Wait, this is for right tail? Theirs must be for the left tail, because that's... Oh yeah, yeah, so it's just a formatting thing in this table. They give 1 minus. Okay, I think I feel confident enough to answer their question. It is a very weird question, so I'm gonna like qualify it a bit. What am I trying to say? Oh shoot, well, actually, their n was 8. 1, 2, 3, 4, 5, 6, 7, 8. So I think they should do n equals 7 and pretend like the 43 doesn't even exist. Your mean standard deviation and sample size. Pretend you have sample size 7 and only use the 43 at the very end. And calculating your answer for T. I think you'll get a very high T score that's off the table. Your interpretation of the answer also seems off. There should be a very low chance getting wind speed that high. The degree of f of f is equal to the degree of f squared, right? If you had to say a cubic composed with itself, that would be degree 9. Yeah, so I think you're right, SPQ. Getting a wind speed of 43 or greater. The or greater part means you'd subtract 1 from 0.995 and get that the chance is actually, or the chance is less than 0.005 or 0.5%. Interpret the question. All right, so let's post that, see what happens. But yeah, this is just in the math for fun part of my Discord, so I'm not gonna worry too much about it. I do kind of want to look at some of the real analysis problems from Zach's stream, because we didn't get through all of them, and I kind of want to think about. I kind of want to see what the rest of what some of the other ones are. So we did 1, we did 4, we thought about 7, which I still don't know what to think about 7, but we did think about it. Let's kind of look like down here, like maybe let's just read through number 8 and see what's up with that. The city of Amazingville, city streets are placed in a grid system. Oh, is there a Pythagorean theorem thing? We didn't actually get to an answer on this. So maybe don't like spoil the end answer, because it's something that I'd like to figure out for myself as like a learning thing, but Pythagorean theorem could definitely be related here, it seems. Taking like the parts of the square. You won't spoil? Thank you. Because it does like visually seem to make sense that the perimeter of this partial square would approach the perimeter or the circumference of the partial circle. Piecewise straight. Yeah, so that's something that like we kind of like leapt up on saying like we haven't actually proven that they converge to the circle segment. I'm not sure why, and I'd like to think about it for myself more before hearing the answer, but I think it's like thinking about this is going to be more of an off-stream thing for me. Because this feels like the calculus formula for arc length. because the general, like, you get the arc length by integration is very similar. It must be different for some reason, but I don't know. For now, I want to like let it marinate. For now, I want to look at 8. This integrated system only north, south, east, west directions are directions of travel with uniform lengths of each block. Dan. Ooh. Danny Highway gets a star in this problem. Dan is standing at a random spot in Amazingville. What are all the locations that are 3 blocks away from Dan? What about n blocks away? Huh. Isn't that just I wasn't in the call. He was an amazing. Well, apparently, Bob. So I guess let's draw this out and kind of think about it. I'm not sure the point of this, like where this problem is necessarily going, but let's see. I mean, I haven't heard that term before. It might be oh, it's just like how you measure blocks. Like I assume that. I guess it depends how you define a block too. Yeah. Or not how you define a block, but like let's maybe set up 5 by 5. 1, 2, 3. Actually, I think we might need more than 5 by 5. Let's do like 6 by 6. So that's 6. 2, 3, 4, 5, 6. It's gonna take I mean, it's 36 dots. It's not that bad. Gonna be a little bit lazy about it though. Okay, so let's pretend. Let's take this red as Dan's location. Is related to number 7? Oh, I guess I could kind of see that. So we're gonna get squares out of this. Method of combinatorics. Amazingville distance, yeah. So all locations that are 3 blocks away. So let's. Oh man, I need to expand my grid even more. Seven by 7 should be enough though. Okay, so the easy things are up, down, left, and right. So 1 block, 2 block, 3 blocks. We can go there. 3 blocks here. If we go in a straight line, 3 blocks in any direction, we can go there. Now I assume we can't loop back on ourselves, but we could go down, right, up, right? And same with any of these other ones that we can also get to all 4 of those. We could also go down, right, right. Almost like how a knight moves. Chess, and also I guess it could be reflected too. Can we just get everywhere? Am I misunderstanding? I mean, I just made 2 squares so far. Oh, okay. Let's like we go down, right, down. That's the same thing. Can we get somewhere that's not here? I guess. Actually, I don't see how. These might be all the possibilities. That's kind of funny. It's like a Pythagorean theorem thing, I guess. I mean, I don't know. If you're going northeast, you have to pick 0, 1, 2, or 3 norths, and the rest are east. Yes. That's 4 northeast locations you can go. Even path to top at some point. There's no odd path. So I guess opposing what Jeff is saying, if you're heading northeast, like in this quadrant, you could go up 1 and then you're left and you have to go 2 east. You could go 2 north and you have to go 1 east. Or you could go 3 north and 0 east, or 0 north and 3 east. Travel east and north, can't go across the diagonal at the same time. I'm not sure even path or odd path. I'm not sure what you mean with like even versus odd, but I do see how like, or I know I like there's some kind of pattern here. Like these 4 inner points have a different nature than like the outer points, if that's what you mean. Or you know, you just don't use the same, I guess, path technique to get there. We can do another thing of dots all around this and look at 4 blocks away as well. Because we do need to work on it for n blocks. An even number of unit intervals. Oh, so you're already thinking about like the n number of blocks. The edge of a diamond for each n. That's what I'm guessing too, Jeff. I guess that's what I would expect to happen. I guess let's try it for ourselves though and see. Let's make a little key here too. Red is Dan. Blue is 3 blocks. And we'll say green is 4 blocks. Okay, so if we travel 4 blocks, let's do the easy ones. Going straight in each direction. Then let's maybe look at 2 by 2. So down 2, right 2. Right 2, up 2. Up 2, left 2. Wait, that's not right. It's counted? Because my dots aren't even. 2, 2, okay. 1, 2, 3, 4. Okay, just want to make sure that was right. Okay. Now we could also go down 3 and left and right 1. Over 3, up and down 1. 3 and 1 and 1. 3 and 1 and 1. So yeah, here's another diamond. Now let's see when we loop back on ourselves. So we could go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. We get a square here. Oh god, I wish I had some more even dots, but it is what it is. Now we could also do 1, 2, 3, 4. Oh, maybe it does turn out to be a diamond. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Oh, so I see like the even and odd paths, we never have overlap here. Within 3 blocks. I think within 3 blocks is like the more practical interpretation. I guess I was interpreting it more strictly, like exactly 3 blocks. Yeah, so I guess that's another question too, like what counts as backtracking, because I definitely wouldn't do like down and then immediately up. I did do down, right, then up. I don't think that's technically backtracking, even though it's an inefficient route. Hmm. So I guess um like there's right triangles everywhere in this. It almost feels like linear algebra 2 with the span of vectors, except you only have like rather than infinitely many vectors, you only have so many. Probably mean a hand distance of 3. Okay. Yeah, exactly. It would be like I was thinking about like the magnitude of each point, where you kind of like imaginarily, I don't know how you're supposed to say that, but you imagine drawing the hypotenuse, and that's kind of like the total distance that you're allowed to go. Hmm. So it may have been cheating. Like I technically did like 1 block and 2 blocks with my inside diamonds. Either way, I think it boils down to like, you know, I did 2 different diamonds for 4 blocks, or you could consider I did a 2 block and then a 4 block, I guess. So I think either way, like what I've drawn is kind of valid. Just maybe I didn't think about it in the best way possible. So it seems like it's just always going to be a diamond. And I guess we've answered the question. Do the same thing in 3D. Well, then you have a cube. What is the next real number after 9? Oh, no. The way that I was taught, I thought there isn't, you can't name it, but well, I mean, I remember talking to Zach a little bit about this. Like, the thing that's in all the rage now is, oh wait, I'm not sharing my browser right. It's like 0.99999 equals 1. And like that kind of idea. I don't know how it works, but that kind of like weird, unintuitive idea. Oh, and Bob, since like we were like in an actual like group, I know it's getting late for you, but if you did want to actually like talk about any of these, I don't mind at all. Cheapest how many neighbors? With L? Well, don't worry, Zach. I don't know what all that means, so... You finished this game of Minesweeper? Okay. So yeah, no, the one I was looking at is this one at the end here. What's the next real number after 9? Hey, Central. Oh man, that wasn't number 9 though? Come on. It's perfect opportunity. You know, let me actually I probably should take a screenshot of what I just did and post it into the little discussion board. Let me do that quick. I'm gonna open up my own stream and take a screenshot. Okay. Got a screenshot. But before I forget, I do want to post this in Zach's Discord. We can hop in my Discord, Bob. If you want to join the waiting room now, I'm just putting a quick thing in Zach's Discord. The drawing below. Get a diamond with diagonals equal to the length of, or twice the length of the box. Okay. Let's get Bob in. Actually, I need to change my mic. 1 second, Bob. Oh no, I'm good.
Hello.
Hey.
What's up?
Nothing much. I just wanted, since I was like working on the realness problem, I just wanted to like invite you to like say anything if you wanted to. So it's kind of worked out. Number 8. I don't know if there's some kind of more realization that we can make about it, but
I just want to say something about the real next number after 9.
oh yeah, sure.
Oh yeah. So, wait, can I stream actually? The screen?
All right, do you mind if I like share it on the stream too?
Yeah, of
Throughout the
course.
shares? Okay.
There we go. So like, there's a little bit of fun fact that I was thinking about. Like, it gets to do something with set theory. So, but first, let's say 9 has like a next number, right?
Okay.
Suppose opposite, and let's call it m, right? And then we can look like 9 plus m over 2 for this number.
Like
And that
taking
would
the
mean,
midpoint?
sorry, m
Oh,
is larger than 9. Let's suppose that m is a next number, right?
okay.
Oh, right. Yeah. You're right. And we know that it is, since m is larger than 9, we know that it's bigger than this, which is 9. And I also know that it's less than m plus m over 2, which is m, right? So in this way, like you show that there is no smallest
Oh,
like next number, right?
so you showed it strictly, but like 9 is strictly less than that is strictly less than 9, and so it can't exist.
Yeah. Like because it's larger than 9 and smaller than that next number. So like you suppose there is a smallest next number, and then you just there cannot be because this one is smaller.
Okay, that makes sense. Maybe the answer to that question is supposed to be that there isn't one. I was wondering if there's like something like tricky with it.
No. But I wanted to say something interesting. Like,
Oh yeah.
if I asked you, like, what's the smallest integer, right? And like, you
Okay.
cannot give me an answer here, right? Because like, you have all these numbers 0, 1, 2, and so on, right? There is no way, there is no smaller because it goes to minus infinity.
Yeah, exactly.
Yeah, but there's something called well ordering in set theory, which would here be like I can do something like this. I can call Z, like I can kind of make an order of way they appear. Let's say 0, -1, 1, -2, 2, -3, 3, and so on. So if I just cover the whole set like in that way, and then I can define that 0 is my smallest number and work like that, you know? That's how I compare the numbers, like
At
without
their absolute value,
corrections.
basically.
Yeah, yeah.
Okay.
And funny thing is about set theory, just to say how wild it is now if you try to do something like that in real numbers, right? Something, I don't know how to do it, right? There's a theorem that says that it can be well ordered. Okay?
Okay.
So there's a theorem saying that this can happen, and then there's another theorem that says you cannot construct it. It's impossible to construct it. So set theory, everyone.
In general, or do you mean specifically like you can do it for Z but not for R?
Yeah, the theorem is like because if there's like some assumption that you cannot do it, then it gets too big, gets some weird stuff, right? But
Okay, like
I'm
just saying
not
the
really
axiom of
sure. I just
choice
know the
that I've
scheme
heard
of
of.
it. I don't really know that much.
Okay.
I just wanted to share that fact, and I think I'm gonna go back to Minesweeper now.
Okay. Yeah, no, I know there's some crazy like contradictions with like the axiom of choice like that can happen in set theory. I
Yeah,
don't know the exact like application here, but I'm sure that there is one.
and like Banach-Tarski stuff. And, you know.
Yeah.
Well, of course, you need the axiom of choice. You will see in analysis, like it's
Okay.
so subtle. Like let's take some sequence. Like how can you take a sequence? What do you mean? How can sequence be arbitrary? What are you doing? It's kind of
Yeah.
necessary in the math, but it brings out such hell that yeah.
I don't know.
Anyways, I'll go back to lurking in your stream.
Okay. Enjoy the Minesweeper. Thanks for saying that.
Thanks. Bye bye.
Bye. Okay. That was no pro Bob. We were doing the Zach's real analysis class together, so I wanted to see if he had anything to like add since I was working on the problems anyway. Given on an empty subset of R, can you choose an element? Okay, yeah. So I've had like it explained to me before, and I kind of like vaguely remember a weird result from it. And I know there's like more than that. It's very weird that being able to choose an element makes so many weird things. I've been going for 2 hours and 15 minutes. Let's take a look at number 9. Wait. Yeah. The set of all spaces the king could move in 2 moves. Now this one actually does allow backtracking to me. But the only real difference is that you include the previous cases. So it's not really that big of a difference. But you will end up with another diamond. King Dan, yeah. Okay, so this one, I haven't actually drawn it out like they ask, but I feel like I basically did draw it out with my drawing for 8, so maybe we'll move on. Actually, should we? It's actually the integers. Should we examine negative moves or 0 moves? Yeah, Bob had a chess problem. Although I don't think it's as complicated as other chess problems can be. Go back with the king. Yeah, so you can definitely include like the previous results. Like if you examine n equals 3, you can also include. Well, could you include 2? Maybe not 2. Maybe yeah. Actually, you could. Maybe you include all the. If it's even, you include all the evens before. If it's odd, you include all the odds before it. I think that's what. I think that's the answer. Okay. So yeah, I feel kind of comfortable with 9. So let's look at 10. F of x equals x, and let a, b be parameters I can change. The figure enclosed by f of x, the positive x-axis greater than 0, and the line x equals b has what area? This is a right triangle. With 40, it's an isosceles right triangle. We can draw this out. I just want to see, let's read. Wait. Is b greater than 0 here, and is b less than 0 here? Or maybe we need to calculate both cases, or equal to 0. Okay, I definitely need to draw this out. So just do a basic xy axes. Let's say f of x. F of x equals x. Okay, so for part A, we have the line x equals b. And A and B have no real conditions on them. So for part A, let's just examine x equals b, where b is greater than 0. So, if b is less than 0, there is no area enclosed by f of x in the positive x-axis in the line. So is the condition implied here that b is greater than 0? Because we just have no area to enclose if b is less than 0 or equal to 0. Okay. Thanks, Zach. I was being too general my thinking, I guess. So fx equals x makes a 45-degree angle with the x-axis, which and that's a 90-degree angle, so this must also be 45. We know the distance from the origin to the line x equals b is b. Oh, hey, BC or, and so I just realized, are you Brian? I didn't know that this entire time. We also know the heights. It's an isosceles right triangle, and by the nature of f of x equals x, we know that the height is also going to be b. So there's a few ways that you could show that. You could plug b in to x here and get b back out, or you could know from the angles that it's isosceles and that must equal that. So the area in this case is 1/2 base b times height b is b squared. 1/2 b squared. You are bright. Pen is also one. You call him Boss Bright. Okay, good to know. So I didn't know that you changed your name again. It's no worries though. Okay, so 1/2 b squared seems reasonable to me. Just doing it geometrically, not with calculus. Although with calculus you get the same thing. So if we now examine the negative x-axis, and x equals b for b less than 0, we can. It's the exact same thing. I'm not going. I'm kind of mixing my colors here, but it's fine. Like, I'm not going to do like the calculus thing of saying that's a negative area, because I don't think that's what we're supposed to do here. Oh, but I see what you mean with that, Jeff, where, I mean, it's an infinite area though, so I don't think that's the point of the problem, but yeah, if you were trying to bound something with x equals a negative value for b of x and the positive x-axis, yeah, you could get an area that goes like there, over there, and over there, but then it just goes out to infinity, so I don't think that's the point of this. The figure enclosed by f of x, the x-axis, and the two lines, x equals a and x equals b, have what area? So here we might have, I mean, I can see 3 cases here that really boil down into 2, and maybe those really boil down into 1. But let's not assume that yet. So the area depends on the context. Yeah. So I don't think we're going to call it a negative area for the sake of this problem, but okay, so then for C, if I kind of want to examine some different cases here, because we've already kind of drawn the case. I mean, I called them B both times, but if we have the case when a is greater than 0, b is less than 0, or a is less than 0, b is greater than 0. Basically, when they're on opposite sides of the y-axis, I would expect that we just add these two together, because we've already kind of done that work. Just that triangle plus that triangle, if that's a and that's b. That seems reasonable to me, so a is equal, actually, well, we need to deal with the 1/2 b squared plus 1/2 a squared. So 1/2 a squared plus b squared. And then let's look at the case where they're both positive or both negative. And we might get the same formula back out. Actually, I think we might get the same formula. When a is greater than 0, comma, b is greater than 0, or a less than 0, b less than 0. So let's draw a second picture here, so we can see what this looks like. So let's just pretend they're both positive, because I think the negative is going to be the exact same case. And we'll take A as our lesser one, but it doesn't really matter either. So I think it was Jeff or someone mentioned a trapezoid. This does seem like a trapezoid. And I feel like the formula for the area is just that exact thing. I don't know if I should prove that. Because it's definitely split up into like a triangle and a square. Or a rectangle. Oh shoot, you know what? The problem is partially, or my graph is partially covered by the problem, isn't it? Just put the problem up there. Call it good. Oh yeah, so Jeff's the one who said, I don't want to put the trapezoid. So I could Google the formula, but let's be overachievers and just look at the actual shape and try and puzzle it out for ourselves. So we have a trapezoid that looks something like that. The bottom here with my construction is B, the top is A. Now, what I'm thinking is we could draw that line to make a right triangle and a rectangle. Actually, will this have to be a square? Can we force it to be a square? No, we can't. We do know that the height is B minus A. And that this must also be the same over here. So I feel like these also have to be 45-degree angles. And that actually, that does have to be a square? If those are 45-degree angles. Because if you were to, like, you know, draw an imaginary horizontal line here, like we did there, you're still making a 45-degree angle. So actually, I think actually, no, I'm sorry. It's not a square, but like, okay, no, never mind. I was thinking of something. Ugh, okay. Basically, this portion would be B minus A. And, oh my god. This portion would be B minus A, which is just A. And so I was thinking it's going to be a square because we get A and A, but of course that would need to be A as well. The A squared over 2 triangle from the B squared over 2 triangle to get the area. Oh my god, you were so right, Jeff. So yeah, what Jeff is saying is you ignore x equal a for a minute, look at just the right triangle that forms with the origin x equals b and the point up there, and subtract the smaller triangle that x equals a forms, and then you're just left over with the area in the middle there. That seems a lot easier. I'm going to follow this train of thought because that's how I was going to do it naturally, but I think your way is way easier, Jeff. And we can verify it at the end. So the area of this rectangle is going to be A times B minus A, right? Plus 1/2 base and height B minus A squared. So I guess let's just multiply it out and see what happens. minus AB plus 1/2 a squared. AB and AB cancel. Minus, or 1/2 b squared minus a squared plus 1/2 a squared is minus 1/2 a squared. So, okay, it does come out to be the exact thing that Jeff said. I did it the hard way, though, because I just do things the hard way, I guess. So we see that when the sign matches, because I think this exact work would transfer over to the other case with a less than 0, b less than 0. We find that a equals 1/2. Oh, wait. This isn't quite right. In some situations, we have b squared, or a squared minus b squared. Yeah, so I caught that a little bit too late. We could see the absolute value, but I feel like that's... I should just impose the conditions on it and give two separate versions of the formula. That feels more appropriate for the context, but that's just like a feeling thing. So we're saying when a is less than b is less than 0, or 0 is less than a is less than b, this formula should hold. I think I need to flip those though, don't I? B is less than a, because we're dealing with negative numbers. That feels better. There was a problem like this earlier today. Shadow case by a lamppost on a person. Oh God, that sounds horrible, Jeff. Only some early math adds up to that. Oh no, Brian, that's a completely fine joke. I just don't like to joke about like things that are like actively like controversial that people are really arguing about, but I don't think people are arguing about OnlyFans. And then, I mean, I don't really have room, but the third case, when a less than b less than 0, or 0 less than b less than a equals 1/2 a squared minus b squared is what I would say. Okay. Basically, a equals b. Oh God, you're right, Jeff. That's a good point. And Jeff, you were asking whose quiz is this? It's not a real quiz. It's more like I mean, it's from Zach. It's for his real analysis class. The first section of which just happened this morning. There's going to be a second section in 2.5 hours. Since a point is not a simple curve, this is like the very first oh, what the heck? I mean, I don't really care that I showed that, but I don't know why that hotkey brought me there. So I guess I was uploading a YouTube video, and I need to remember to actually update it after this stream. But so this is like the very first thing of real analysis. It's like, you know, the online course that I just started this morning, so it's like just barely starting to introduce ourselves. But what we're doing on the stream is a lot of it was just working on this first prompt with inscribing regular polygons into a circle and observing that they the area of those polygons will approach pi as their number of sides increases. ASDZX, a whole bunch of letters. Thanks for the follow. You must have to hit remember me when you log into a site. I don't know how you remember that username, but thank you for following. Oh, and actually, let's look at the phrasing of the question, because A equals B might just boil down to 0. Yeah, if it's enclosed between x equals A and x equals B and A equals B, I think you have 0 area here. So, I mean, let's be complete about this. Okay, I think that's enough. Oh no, Jeff, I actually like. So I forgot to examine that case, and that's a habit that I need to get into. So I don't mind you doing that at all. A equals 0 or oh god, A equals 0. Well, no, that the formula is okay with A equals 0, B equals 0. Oh, but I didn't actually, my formula doesn't include it. I could say less than or equal to though, right? Because I could just... Oh man, okay, you know, instead of trying to make all these individual cases work when... It's kind of annoying to have the signs. Well, actually, well, no, here it's okay to... No, I think we just make them all or equal to, because if they're both 0, we should get 0 area and the formula still works. And if one of them individually is 0, the formula works. So for that one, it's okay. For this one, I think we can do this and be okay. I think my formulas still work. I just needed to construct them better. I also need to state the conditions better. Because when A equals 0, this formula still works. Okay. It's your first lesson for Stump the Streamer. Okay, I'm happy. I think I'm happy with this. I hope I'm not missing anything else. Yeah, I think it's like a very like baby's first analysis problems, just to like get us thinking about concepts that I think are going to come up more in the future. So let me take a screenshot of what I just did here too, and post that, because I do want to make sure that I'm posting the things that I'm doing into the Discord. 7 and the number after 9 are pretty tough. Yeah, I mean, the number after 9 one is... I feel like there's rigorous ways to do it and non-rigorous ways to do it. And I don't know, like, where the solution that Bob said falls on that. But it was good enough for me, at least. Sorry, I just opened up my own stream and took another screenshot. Oh no. Oh wait, no. No, my phone died.